Yes, so my name is John Polanski, and we had a very nice discussion on global space applications using the LeanSat approach. So I know I don't have much time, but I actually want to talk to everyone about this term, lean satellite. So what is a lean sat or a lean satellite? This has come out of some discussion in the community, and now it's taken the form of a working group on this topic. And what we've determined as a community is that mass and size are not suitable to define or capture the types of satellites that we're building. Satellites that have a different design philosophy related to manufacturing, the mission, the management, et cetera, et cetera. So as you can see here, lean satellite is meant to capture aspects of the following. It's not limited to this, but low-cost satellites, experimental satellites, agile, flexible, creative satellites, small-scale satellites, compact satellites. Any satellite that fits this lean philosophy could be under the definition. And why are we doing this? What are the benefits of lean satellites, these missions, these concepts that have been springing up and have been put into orbit in the last few years? These are some that we talked about in the group. And of course, there are more than this. But at least these lean satellites are low cost relative to traditional satellites. They provide ownership, dedicated use, which means quick response, no queuing, as opposed to using a more expensive traditional satellite that might have a long list of customers and you are just one of many paying for the service. Number three, short development time, which means state-of-the-art technology can actually be realized on the mission within months or years, as opposed to 5 years or 10 years or even longer for traditional satellite programs where the technology is almost obsolete by the time the satellite reaches orbit. Number four, flexible and creative missions are possible using different design philosophies, non-traditional design philosophies. And of course, research and development. Very good for universities and for companies that want to demonstrate or test new technologies. And finally, many people here are participating in human resource development programs that take place on the order of months or years, which is very suitable for postgraduate education, master's degrees, PhDs, even in the bachelor degree curriculum. So there are many benefits of lean sats. And we talked about a lot of different mission ideas, but one that we spent some time on was this low-cost equatorial communication network. And this came up during the pre-MIC 4 yesterday. And what we talked about in the group was the following. In the equatorial regions between plus minus 10 degrees latitude, based on some study by the students, there are around 100 million people who have no connection whatsoever. No cell phone, no internet, no messaging services. And the goal, from a cost standpoint, because these people are very poor, is to provide the messaging service plus the device for a cost of $1 per year. I think it could be enough for those people to pay. If we assume that 1% of the market is captured, there would be an annual revenue of $1 million USD, which is very small for a satellite constellation. So with the LeanSat approach, based on the numbers, probably the constellation could be designed and maybe even launched. But how do we raise funds for the devices, the cell phone or whatever that the users actually use? So we talked about some ideas like selling advertising space on the user terminals so companies can put their logos, they pay to advertise, or embedding a message in every text that is sent, for example, dedicating 10 characters out of the 160 character limit to the company, or seeking charitable donations to support the device for users. We also talked about a possibility, it might be difficult from a legal standpoint, but a possibility of doing training and extracting value from existing satellites at not the end of life from a hardware or software standpoint, but when an educational satellite launches and achieves its mission, it may have more value to another institution, a different party than the party who actually built and operated the satellite. So barring the legal issues and the transfer issues, maybe one consideration would be to provide educational opportunities for others. I know people have done this or have tried to do this before, but it's something that we should keep in mind. And one more slide. We talked at the very end about human resource development and how difficult it is for engineers from developing countries who come to Japan and Europe and the United States. They get training, but they go home and maybe space engineering jobs do not exist. So I think there are other working groups that are addressing this topic, but we just mentioned 2 points. One, to consider careers in related fields. Not to change careers completely, but for example, talking to the UN centers and considering working on applications of satellite data. And I know Werner Balog from the UN is here, and he would love to talk about this more. I hope he can come up later. And also, we talked about how educational institutions should include at least a segment in the curriculum, not just about designing and building the satellite, but also teaching the students how to present the value of the final project to the stakeholders in their country, like the government or a company. Showing the students how to convince someone that the satellite service or data or product is beneficial and useful to initiate the activities at home. Okay, I think I went over my time, so thank you for listening. That's it for our group.
Thank you very